What is my title? A million experiments. I need help. What do I mean? Well, I mean, I literally have a million different experiments planned that I need to do in creating and testing different designs with my hydrogen reactors, my monoatomic reactors, saltwater batteries, coils, and electrolysis and plasma reactions and experiments, just to name a few. And, well, it's a lot of work. I do have the material, though, but there's meters upon meters of titanium and copper that needs to be stripped from really thick rubber and then unwound after that. It's a process. Um, and there's stripping all the copper wire, and then there's winding it all, and then there's cutting all of the PVC pipes. Another part of many of the reactors in developing the battery cell technology itself. Um, there's a lot to it. Then I also got two semi-working massive John Deere excavator batteries to play around with and experimenting. And then, of course, there's all the monoatomics. These ones being rinsed to be dried out. And once in the powder form, a whole other ridiculous amount of new experiments also needing to be done. But on top of the experiments, it's also testing that needs to be done and funding of lab tests or lab equipment for myself to be able to run the tests myself at a much cheaper and affordable and trustworthy reactions. So, lots of work I've been doing the last couple days. You can see the pinkish red state aluminum, iron, copper hydroxide there, potentially the black state as well from it. Here we have it in some white states, exact same stuff. Orange, pink, white state, black state. Some yellow, red state. Have to harvest it all more with black state. Separate it. Sponsored by Wendy's, you know it, Ross. Hey, that's the thing, making these experiments affordable to all. This is interesting. The red ring, it's the pink-red hydroxide that formed, but it literally settled in an actual ring. Wild stuff. Not the first time that it's done that. Fine example of self-organization happening there. This little reactor bubbling away. We got some bubbly, hydrogen bubbly. No, that's not bubbly. It's a bubbling. Is Wendy's gonna show the bubbling? Oh, there you go. almost see it, but not quite on that resolution. It's a much smaller bubble coming off of the anode side. And that reaction, and we got a bunch of silver that has turned a goldish color. Interesting. Some silver and zinc and titanium, that reaction. Zero current through this one, zero current through that one, 5 volts in that one, 0 in this one, 5 volts in this one. That's actually the anode on the right side bubbling crazy like that. Cathode on the left. But everything in there is attached to the cathode and it's bubbling, producing hydrogen, the zinc, the iron, the copper, all connected to the 5 volt negative. And then the aluminum piece right there with the copper going in, that's connected to the positive. And you can see coming out of a cut off USB charger down to the power supply. A little Samsung 5 volts. Oops. Quite a lot of hydrogen off of just 5 volts. The floating monoatomic plasmid clouds suspended. Completely sealed. Is that able to show the, yeah, I kind of see the pink red state of that copper pipe as well as that one, and the white monatomic, even though I had some oxides, blue at the bottom. When I started this reaction, just to experiment with it, and still the monoatomics being produced in this reaction, being monoatomic, not oxidizing, even though there's the previous oxides in there. And, well, that's not an easy feat to reproduce. We'll just say that. Usually, as soon as you get a little tiny bit of blue oxidization, everything oxidizes. There you can see the red, pink, purple state, aluminum, copper, iron, and it looks like some goldish colors, and then the black. Oh yes, and also the aerogels forming on the top. Yes, that's pure jelly metal. You got titanium, copper, iron, and that reaction of aerogel production. nanogel, both oxidized and monatomic. See the aluminum turning into the pink-red state as well. And that was an anode, and it's 808 to that crazy pointy spike point. And then we got this structure. Very interesting creation. And I meant, here we go, empty jar. Empty jar. Let's take a little look-see at what we're working with here. Oh, Wendy's. And for the record, Canadian fast food burger places, especially in Alberta, where they use Alberta beef, exponentially better than the crappy Venezuelan beef that the American fast food places use. Thus, Wendy's is half decent in Canada. Not too much going on in that one. Although, some interesting nano layering at the bottom. There's some nano coating on the iron. Alright, look at that goop. You do not want to consume that, or you might cut your life short. This one's interesting. Got some iron sphericals. Interesting growth. Oh my, look at that weird structure that has grown off the base of it. Interesting. It sucks because these structures were obviously exponentially larger in the water. Just very, very delicate. And there we have like orange state copper. And the different nanotube materials and transmutational states of metal elements that Sir Isaac Newton talks about. As well as the pink and white states of metal. Some of the nanostructures. Alright. How do I do this without breaking more? Have to put down the camera for a minute, momento. I don't know. Maybe on that note, we'll just call this stream. And I'll be back in a little bit with Hans Dietrich for a Woo Woo Wednesday episode. Full stream coming in half hour's time. We will see you all there. Ta-ta.